Something just flew through our solar system that was not born here. It came from another star. It crossed trillions of miles of empty space, completely uninvited. And when scientists finally got a close enough look at what it was made of, they found chemistry nobody has ever seen on a comet before. This is only the third object like it ever confirmed in human history, and it just rewrote what we thought we knew about how solar systems form. Let's talk about Comet 3I/Atlas. Most comets in our night sky were born here. They formed billions of years ago in the same cloud of gas and dust that made the Sun, the Earth, and everything else in our solar system. They are basically local, homegrown, made from our own leftover ingredients. 3I/Atlas is not one of those. The I in its name stands for interstellar. It means this object formed around a completely different star, in a completely different part of the galaxy, long before it ever got anywhere near us. It was discovered on July 1st, 2025, by a NASA-funded telescope network called ATLAS, based in Chile. The telescope's entire job is scanning the sky for exactly this kind of object, something moving too fast, on a path too strange to have come from anywhere inside our solar system. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. It is part of NASA's Planetary Defense Network, a set of telescopes built primarily to spot dangerous asteroids before they get anywhere near Earth. This time, instead of catching a threat, it caught something far rarer, a visitor. Once the discovery was reported, astronomers went digging through older archived images from other survey telescopes and instruments, hunting for earlier, unnoticed appearances of the same object. They found some, dating all the way back to mid-June 2025, sitting quietly in the data, unrecognized until someone finally knew what to look for. When it was first spotted, it was still about 410 million miles from the Sun, cruising along inside the orbit of Jupiter. And the moment astronomers calculated its trajectory, they knew instantly. This thing did not just come from far away. It came from somewhere else entirely, and it is never coming back. This is only the third interstellar object ever confirmed passing through our neighborhood. The first was Oumuamua in 2017, a strange, cigar-shaped rock that baffled scientists for years. The second was Comet 2I/Borisov in 2019, and now 3I/Atlas. 3 visitors, ever, in all of recorded human history. Stick around, because the chemistry hidden inside this comet is about to reveal something even stranger than the fact that it exists at all. Before we get to the chemistry, you need to understand just how fast and how ancient this thing really is, because the numbers alone are enough to stop you in your tracks. 3I/Atlas is moving at roughly 58 kilometers per second relative to the Sun. That is over 36 miles every single second. It is the fastest of all 3 known interstellar visitors, faster than Oumuamua, faster than Borisov. At its closest approach to the Sun, gravity accelerated it even further, pushing its speed up to around 153,000 miles per hour. For a brief moment, our own star's gravity grabbed hold of it and gave it a boost, the same way a slingshot snaps forward right before the release. But the Sun could never actually catch it. 3I/Atlas is moving on what astronomers call a hyperbolic trajectory. That is a fancy way of saying its path is not a loop. It is not an orbit. It is a straight-through pass. It came in from deep space, swung around the Sun once, and it is already on its way back out, never to return. Here is where things get almost hard to comprehend. Based on its trajectory and its motion through the galaxy, researchers estimate that 3I/Atlas could be somewhere between 3 billion and 11 billion years old. Let that number sit for a second. Our entire solar system, the Sun, the Earth, everything you have ever known, is about 4.5 billion years old. There is a real possibility that this comet is older than our solar system itself. One researcher studying its origin put it simply: this object may have come from a star that does not even exist anymore. Think about what that actually means. Stars live for billions of years, then they die, some quietly fading, some exploding. If 3I/Atlas really is 11 billion years old, the star it originally formed around could have burned out, collapsed, or exploded long before humanity, before Earth's continents even looked the way they do now. before life on our planet had even crawled out of the ocean. This comet may be an orphan in the truest sense, cut loose from its home system by some ancient gravitational encounter, maybe a close pass by another star, maybe a disruption during a chaotic period of planet formation, and then left to drift, alone, through the freezing dark between stars for longer than almost anything else we have ever directly studied. Scientists believe 3I/Atlas likely originated in what is called the galaxy's thick disk, an older, puffier region of the Milky Way, filled with ancient stars that formed way back during a period sometimes nicknamed cosmic noon, a time roughly 9 to 13 billion years ago when star formation across the galaxy was at its most intense. If that is true, this comet is not just a visitor from another star. It could be a physical relic from one of the earliest chapters of our galaxy's entire history, drifting alone through interstellar space for billions of years before it ever crossed paths with us. We are not just looking at a rock from somewhere else. We might be looking at one of the oldest objects any human being has ever directly observed. Now stick with me, because this is where NASA's most powerful telescope enters the story, and where things get even weirder. Here's the thing about Oumuamua, the first interstellar visitor ever confirmed. It was basically dead. No gas, no dust, no tail. Just a bare, tumbling rock giving scientists almost nothing to study. 3I/Atlas is different. It arrived active, even while it was still 4 times farther from the sun than Earth is. It was already surrounded by a glowing cloud of gas and dust, called a coma, streaming off its surface as sunlight slowly warmed it. That coma is exactly what scientists needed. Because a coma is not just a pretty tail trailing behind a comet. It is a chemical signature, a fingerprint, literally a cloud of the comet's own raw ingredients, boiling directly off its surface into space, where telescopes can read them. So NASA pointed its most powerful instrument at it, the James Webb Space Telescope. Webb used something called a mid-infrared spectrometer, an instrument that splits light apart into its individual wavelengths, the same way a prism splits sunlight into a rainbow. Except instead of colors, this reveals chemical elements hiding in the light itself. For the first time ever on any interstellar object, Webb detected methane gas. Let that sink in. Methane. On a visitor from another solar system entirely. And that detail alone is not just interesting, it is deeply strange. Methane is a highly volatile substance. That means it evaporates into gas almost instantly once it gets any warmth at all. If 3I/Atlas had methane sitting right on its surface, it should have burned off ages ago, the second it entered our solar system and started warming up. But it did not disappear right away. Scientists now believe the methane was buried, hidden deep beneath the comet's outer layers, protected from the sun's heat until the comet got close enough for that warmth to finally reach down into its interior. Which means what we are seeing now is not the comet's surface. It is a piece of its ancient, frozen core, material that has been locked away, untouched, since before it ever left its home star system, possibly billions of years ago. We are looking at a sealed time capsule from another solar system, one that has stayed shut for longer than most human concepts of time can really account for. Now here's where it gets even more interesting, because the methane was not the only surprise. Webb also confirmed something else. 3I/Atlas is unusually rich in carbon dioxide, far more carbon dioxide, relative to water, than almost any comet ever measured in our own solar system. Most local comets have a fairly predictable ratio of water to carbon dioxide to methane. It is basically a recipe, and nearly every comet born here follows a similar version of it, shaped by the same conditions that built our own sun and planets. 3I/Atlas does not follow that recipe at all. Scientists say this points to something huge. This comet did not form anywhere near our sun. It likely formed in a much colder environment, around a completely different star, with a completely different chemical makeup than the cloud of material that built our own solar system. In other words, this is not just a rock from somewhere else. It is a sample of a different solar system's blueprint, a working recipe from an alien kitchen delivered straight to our doorstep. And we did not have to travel anywhere to get it. Stay with me, because there is another instrument that got a look at this thing too, and what it found adds a whole new layer to the picture. While Webb was reading the comet's chemistry, the Hubble Space Telescope was watching its shape. Hubble captured images showing a teardrop-shaped cocoon of dust streaming off the comet's solid, icy core. Based on those observations, astronomers estimate the nucleus itself, the solid heart of the comet buried inside all that dust and gas, is somewhere between about 1,400 feet and 3.5 miles across. Small on a cosmic scale, but large enough to have survived a journey across the galaxy that may have lasted billions of years, drifting through the freezing vacuum of interstellar space completely unprotected. Think about everything that object has been through. No star to orbit, no sunlight to warm it, just constant, brutal, absolute cold, for longer than most stars in the sky have existed. And it survived intact, right up until it drifted close enough to our sun for us to finally notice it. Compare that to Oumuamua, the very first interstellar object ever confirmed back in 2017. That object showed no coma, no visible gas, nothing streaming off it at all. It was small, oddly elongated, and tumbled through our solar system so quickly that astronomers barely had time to study it before it was gone, leaving behind more questions than answers. Then came 2I/Borisov in 2019, which behaved much more like a normal comet, with a visible coma and a composition that looked broadly similar to comets born in our own solar system. 3I/Atlas sits in its own category entirely. Active like Borisov, but chemically stranger than anything either of the first two visitors showed us. 3 interstellar objects, 3 completely different stories, discovered just 8 years apart. If that pattern holds, and it very well might, our galaxy could be far more crowded with drifting, ancient debris than anyone assumed even a decade ago. Now stay with me, because this is where scientists start asking the bigger question. If this is what one interstellar comet looks like, what does that tell us about the countless solar systems we have never visited? For decades, everything we knew about how planets and comets form came from studying just one example: ours. It is the only solar system we could actually reach out and touch directly. Every model, every theory, every simulation about how solar systems build themselves was based on a sample size of 1. 3I/Atlas changes that. It is direct, physical evidence of chemistry from an entirely different star system. Not a guess, not a computer simulation. Actual gas, actually measured, actually escaping from an actual object that formed somewhere else in the galaxy, at a different time, under different conditions. And the molecular ratios inside it point to something specific: a colder, more distant formation environment. A place where ice could lock in chemicals like methane in different proportions than anything typical around our own sun. Some researchers now believe interstellar comets like this one might carry entirely different chemical fingerprints depending on which kind of star system and which era of the galaxy they came from. Which means every new interstellar visitor we catch could be like flipping open a new page in a cosmic recipe book, one solar system at a time. Here's a way to picture it. Imagine you have only ever tasted food from one kitchen your entire life. You would naturally assume that is just how food works. Same ingredients, same proportions, same techniques every single time. Then one day, a dish arrives at your door from a kitchen on the other side of the world, made with ingredients you have never seen combined that way before. Suddenly, you realize your one kitchen was never the whole story. It was just one recipe out of countless possible variations. That is exactly what 3I/Atlas represents. Not proof that our solar system's formation was wrong, but proof that it was never the only way to build one. Somewhere out there, a colder, older star system built its planets and comets out of a completely different ratio of ingredients, and a fragment of that process just drifted straight past us. We just do not know yet whether 3I/Atlas is a rare exception or a completely normal example of what is quietly drifting out there by the thousands. And that question alone is enough to keep astronomers chasing the next one. Here's what makes this moment even wilder. 3I/Atlas is not sticking around. Interstellar objects like this one are not in orbit around our sun. They are just passing through, on a one-way trip that started somewhere else in the galaxy and will end somewhere else entirely, possibly billions of years from now, around a star that has not even formed yet. Once it swung past the sun and slingshotted back out into deep space, that was it. Forever. No second visit, no follow-up mission, no chance to send a probe out to catch up with it before it vanished completely. The comet's closest approach to Earth came on December 19, 2025, and even then, it stayed nearly twice as far from us as the Sun is, at about 170 million miles away. There was never any danger to our planet, but it was also our only window. A few short months to study material that took possibly millions or even billions of years to arrive. And in that window, Webb managed to pull off something remarkable. The very first mid-infrared chemical fingerprint ever collected from an object born around another star. Every single observatory that got a look at 3I/Atlas during those few months was racing against a clock that could not be paused, rescheduled, or extended. Astronomers around the world reorganized their observing schedules, competed for telescope time, and coordinated across continents, all to squeeze out as much data as possible before the comet slipped back into interstellar space for good. There was no room for delay. Once 3I/Atlas crossed back outward past the orbit of Jupiter, it would keep accelerating away, fading from even our most powerful instruments within months. Whatever data was not collected during that narrow window would simply be lost, permanently, along with the object carrying it. Scientists are calling this a breakthrough moment for an entire new field, sometimes called interstellar object science, a field that barely existed a decade ago and now has 3 real subjects to study, each one stranger than the last. There is also a deeper question hiding underneath all of this, one that goes beyond just chemistry. Every comet like this one carries with it the same basic raw ingredients that, under the right conditions, can eventually lead to the building blocks of life: water, carbon-based molecules, organic compounds locked in ice. If interstellar comets like 3I/Atlas are constantly drifting between star systems, seeding them with these same basic ingredients over and over across billions of years, it raises a genuinely open question in astrobiology. Could objects exactly like this one be part of how the raw materials for life get scattered across an entire galaxy, star system to star system, completely independent of any single world's own formation? Nobody can answer that yet, but it is no longer just a science fiction question. It is a real, testable idea. And 3I/Atlas is one of the first concrete data points we have ever had to actually study it with. Naturally, an object this bizarre did not stay out of the public conversation for long. A discovery this strange, this old, and this fast, moving on a path nobody predicted, was always going to invite big questions. Some researchers even publicly floated the idea that an object behaving this unusually deserved a careful look for any signs of artificial origin, before the overwhelming evidence settled it firmly as a natural comet. That kind of scrutiny is normal in science. Extraordinary objects get extraordinary questions asked of them, and in this case, the chemistry, the shape, and the behavior all point to something completely natural, just from somewhere we have never been. So think about what just happened here. A frozen fragment, sealed since before it ever left its home star, possibly older than our entire solar system, drifted across the galaxy for who knows how long, arrived at our doorstep completely uninvited, got read by our most powerful telescopes, and revealed a chemical signature unlike almost anything born in our own solar system. Then it left, and it is never coming back. We did not go looking for another solar system's secrets. Another solar system sent them straight to us, and we happened to be paying attention at exactly the right moment, with exactly the right telescope, at exactly the right time. That is the real story here. Not just that this comet exists, but that we caught it, we read it, we understood a piece of its origin before it vanished back into the dark, on a journey with no destination and no return trip. And here is the part that should really keep you up at night. Astronomers only started reliably catching objects like this a decade ago. As new sky survey telescopes come online with far greater sensitivity than anything used before, scientists expect to start finding interstellar visitors far more often than just once every few years. Some researchers believe we may eventually detect dozens, even hundreds of these objects passing through, each one carrying its own frozen chemical record from a different corner of the galaxy. For most of human history, we assumed our solar system was essentially isolated, a closed system, floating alone in the dark, separate from everything else out there. 3I/Atlas is one more piece of evidence that this was never really true. Our solar system is not sealed off. It is more like a busy intersection, and every so often, something from an entirely different part of the galaxy passes straight through it, completely by chance. We are not just observers sitting still in one place. We are constantly being visited, brushed past by fragments of other worlds, other star systems, other chapters of the galaxy's history, most of the time without ever even noticing. 3I/Atlas is simply the first time in a long while that we happen to be looking in exactly the right direction, with exactly the right tools, at exactly the right moment to catch one. Somewhere out there, right now, there could already be another one on its way in, completely unnoticed, carrying secrets from a star system we will never otherwise see. If this blew your mind, you need to see what happens when a runaway supermassive black hole gets kicked out of its own galaxy and leaves a trail of newborn stars behind it. I made a full video on that. Watch it next. And if you want more of these deep space mysteries delivered straight to you, hit subscribe, because this channel is just getting started.